Welcome back, space enthusiasts. In today's special Q&A episode, we're diving deep into some of the most intriguing cosmic queries you sent our way. We'll explore the potential of a bigger James Webb Space Telescope for SpaceX's Starship, what a day on a gas giant might look like, and who really holds the keys to cutting-edge scientific discoveries. Strap in and prepare for a journey to the edges of our current scientific frontiers. Here's a more engaging rewrite of your script. Ever wondered about the mysteries lurking beneath the icy oceans of Europa? Or how you'd measure a day on a colossal gas giant? What about witnessing a total solar eclipse from the surface of the moon? We'll explore these cosmic curiosities and more in this week's thrilling episode of The Question Show. Welcome, everyone. This is The Question Show, where your curiosities fuel our journey through the cosmos. I'm here to tackle your most intriguing space questions. No matter where you are or what channel you're tuning in from, if a question sparks in your mind, jot it down. Send it over, and I'll address it right here in our next episode. Now, let's dive into this week's intriguing inquiries. First up, we have a question from Kenneth. Does anyone know how the pressure in Europa's ocean compares to Earth's ocean depths? Great question, Kenneth. Europa, one of Jupiter's most fascinating moons, is wrapped in a thick, icy shell that hides a vast ocean of liquid water beneath. But here's the twist. We're not quite sure how thick that ice is or the exact depth of the hidden ocean. While I can throw some estimates at you, they might be off the mark. We're eagerly awaiting more precise data from upcoming missions like NASA's Europa Clipper, launching this year, and the European Space Agency's JWST mission, which is already en route. Both are set to unveil Europa's secrets in the early 2030s. Next, we embark on an extraordinary venture beneath Europa's icy facade. Our mission? To probe the depths of the ice, decode Europa's gravitational mysteries, and pinpoint the elusive boundary where ice gives way to ocean, and then to the rocky core below. But remember, the insights I share today are just the tip of the iceberg. Future missions will bring us the full story. Imagine standing on the brink where Europa's icy shell meets its hidden ocean. If you were there, beneath a 20-kilometer thick layer of ice, imagine the colossal weight of that frozen water pressing down upon you. It sounds overwhelming, right? But here's where Europa throws a curveball. Its gravity is only a fraction of Earth's, about 1/17. So, let's crunch some numbers. With that reduced gravity, the pressure exerted by 20 kilometers of ice would feel like being 2.7 kilometers underwater here on Earth. That's immense, yet within the bounds of what our technology could handle. And the ocean itself? It's believed to stretch down 100 to 200 kilometers deep. At Europa's weaker gravity, this translates to pressures between 130 to 260 megapascals. It's a hostile and mysterious environment, and one we're just beginning to imagine exploring. Imagine diving into the deepest parts of Earth's oceans, then multiply that challenge exponentially. That's what we're up against as we plan to explore the alien oceans of Europa. Initially, our robotic explorers will need to withstand pressures equivalent to being 2.7 kilometers under Earth's oceans. But that's just the beginning. As these intrepid machines venture further into Europa's depths, aiming to reach the ocean floor and investigate phenomena like the enigmatic black smokers, they'll encounter conditions unlike anything we've ever managed on Earth. The pressures there can simulate depths between 13 and 26 kilometers beneath our ocean, a realm far beyond our current capabilities, as no part of Earth's ocean reaches those depths. And speaking of challenges, did you catch the Star Trek planet popping up in our earlier segment? That's your cue to engage. Tell us what you think. Last week ended in a four-way tie, with questions from Dreamcast KN3 Dog, Cosmic Collisions, and Nomad 77 CA, all capturing your curiosity. Vote and let us know your favorite question this week. Thanks for joining this cosmic adventure. Now, on to a fascinating query from Randall Hensler. Randall asks, Shouldn't they build a new iteration of the James Webb Telescope to fit inside SpaceX's new Super Heavy rocket? Great question. When the James Webb Telescope launched, it was snugly packed inside an Ariane 5 rocket, which has a fairing size of about 5 meters in diameter. The entire telescope was ingeniously designed to fold into this space and then unfurl in orbit. Its primary mirror alone stretches 6.5 meters, larger than the Ariane's fairing. But here's where it gets interesting. SpaceX's Starship boasts a fairing size of 9 meters across, nearly double that of the Ariane 5. This extra space could revolutionize how we design and deploy future telescopes. Imagine the possibilities with a sunshield the size of a tennis court, not just folded up, but possibly even larger, enhancing the telescope's capabilities beyond our current constraints. The universe might just have gotten a little bit closer. Let's shift gears and gaze upward. How massive could a telescope get if it hitched a ride with SpaceX's Starship? Imagine the possibilities with a fairing that spans 9 meters wide. There are essentially two routes we could take here. The straightforward path, where we use that expansive 9M fairing to house a colossal yet simple telescope. Consider the iconic designs of telescopes like Hubble, Spitzer, and Herschel. These aren't just pieces of technology. They're like time capsules capturing the cosmos, all designed as tubes with primary and secondary mirrors, neatly packed into the spacecraft engineered for their journey. So what if we utilized Starship's generous dimensions? We could potentially craft a telescope around 8 meters in diameter. This would not only be the most formidable telescope ever launched by humanity, but a leap forward in our cosmic exploration capabilities. Such a telescope could rival, or even exceed, the ambitious designs of future projects like the LUVOIR telescope and the Habitable Worlds Observatory, which are planned to be around 6.5 meters. Imagine the potential if SpaceX's Starship enables us to think bigger literally. Even on a disposable basis, the feasibility of creating a behemoth telescope that could offer unprecedented views of the universe is a tantalizing prospect. The question isn't just can we, but how far can we go? In peering deeper into the mysteries of the stars, imagine if we stripped back the complexity and simply aimed for size a telescope, like the iconic Hubble, but scaled up dramatically within a 9M fairing. Picture this: an 8-meter wide telescope, a straightforward tube within a tube, vaulting into the cosmos. Compared to Hubble's 2.6 meters, we're talking about a game changer that could potentially double the capabilities of the James Webb Space Telescope. This behemoth would be equipped to handle ultraviolet, infrared, and visible light, complete with a coronagraph to reveal Earth-sized planets orbiting Sun like stars. But what if we dared to dream even bigger? What if we took a leaf out of James Webb's book and crafted a folding telescope that could snugly fit into a spacecraft like the Starship? The possibilities are staggering. We could be looking at a telescope well over 10 meters, perhaps even approaching 20 meters in diameter. Imagine unfolding such a giant in space, ready to peer deeper into the universe than we ever have before. However, embarking on such an ambitious project isn't without its hurdles. Remember the challenges faced by the James Webb team, perfecting every intricate component, managing the weight, and watching the budget balloon to a staggering $10 billion. Yes, dreaming big comes with hefty challenges, but the potential to unlock the universe's deepest secrets? Absolutely priceless. Let's shift our gaze to the future of space telescopes. The hard lessons learned from the James Webb Space Telescope, with its overblown budget and delays, have reshaped our ambitions. The next astronomical titan might not strive for the complex and costly paths previously taken. Instead, imagine a robust, on-time, and on-budget project reminiscent of the straightforward designs like Hubble or the Nancy Grace Roman telescope. Simple, effective, a tube within a tube. But here's where it gets truly exciting. What about building a telescope right in orbit? Picture this: instead of sending up a whole telescope in one go, we send up pieces, like we did with the International Space Station. Imagine launching the main body with robotic arms first, followed by the primary mirror, piece by piece. These robotic arms, or maybe even astronauts, could assemble it in space. The possibilities for innovation in orbit are boundless. And with something like the Starship, which promises to drastically cut the costs of lifting heavy payloads into orbit, we're on the brink of a revolution. While Starship's full potential is yet to be confirmed, even the less optimal outcomes could dramatically change the game. Imagine, even if each launch requires sacrificing the Starship and super heavy, the capability to send significant mass into orbit economically could be a game changer for building our next great eye in the sky. When you gaze at Jupiter, you might think it's all spinning uniformly, but that's far from the truth. The speed at the equator is actually different from the speed at the poles. There's a variance of several minutes. This brings us to an intriguing point. Which part of Jupiter are we even talking about? The planet is enveloped in powerful, differential wind speeds that cause different sections to rotate at varying rates. Consider the Great Red Spot, a gigantic storm larger than Earth itself. It completes a full rotation in about 9 hours and 50 minutes. That's one way to measure Jupiter's rotation. But what about deeper inside Jupiter? Could there be a solid core, and if so, how fast does that rotate? The key to unlocking this mystery lies in Jupiter's magnetic field. It's incredibly strong and distinct, a beacon that guides scientists in measuring the internal dynamics of this gas giant. By studying the magnetic properties emanating from Jupiter, researchers can infer the rotation of its hidden core, even though they can't see it directly, like the solid surfaces of Mars or Mercury. For Jupiter, scientists have a neat trick up their sleeve. They monitor the magnetic field features that rotate with the planet. By tracking when these magnetic features return to their starting point, astronomers can clock Jupiter's day at about 9 hours and 50 minutes. It's like watching for a landmark to appear again as you spin in a swivel chair. But Saturn? That's where the plot thickens. Just a few years ago, if you asked a planetary scientist about Saturn's rotation speed, you'd likely get a shrug and an uncertain guess something around 10 hours and 30 minutes, but with no real confidence. Saturn's cloud speeds are all over the place, and unlike Jupiter, its magnetic field doesn't offer clear, consistent markers. This made traditional methods fall short. These standing waves, captured in the data from the Cassini spacecraft, held the secret to Saturn's elusive rotation speed. It wasn't until 2019 that astronomers cracked the code, revealing that Saturn completes a full rotation in 10 hours, 33 minutes, and 38 seconds. But this discovery is just the tip of the cosmic iceberg. The hunt for planetary rotation speeds is a thrilling adventure that takes us across the galaxy. From scanning the swirling atmospheres of gas giants to tracking the subtle dance of magnetic fields, astronomers employ a myriad of techniques to uncover the mysteries of celestial spin. Yet there's more to it than meets the eye. Planets like Jupiter and Saturn, spinning so rapidly, bulge at their equators, forming what can only be described as squished spheres. But how do we measure this cosmic salsa timing? Enter the cosmic choreography. Interactions with other planets and cosmic phenomena give these squished spheres a gentle nudge, revealing their rotational rhythm. Imagine this: the planets align, and suddenly our moon transforms into a cosmic football, spinning gracefully in the celestial arena. But understanding its rotation has been a cosmic challenge. While methods like tracking its rings have been attempted, they often fall short of accuracy. However, one method stands out as the champion the rings of Saturn. Their precise dance provided astronomers with the elusive answer they sought. Now, let's turn our gaze to another cosmic spectacle, a total solar eclipse seen from the moon. Alex, you've hit the jackpot with this question. Picture this: I recently had the privilege of witnessing a total solar eclipse from Dallas. Clear skies, the corona shimmering, it was a sight to behold. But what about from the moon's perspective? Here's the cosmic play-by-play. Imagine being in space, watching as the moon's shadow dances across Earth's surface, engulfing regions in darkness. Fortunately, our cosmic voyagers, the astronauts aboard the International Space Station, had a front row seat. Orbiting high above Earth, they witnessed the eclipse firsthand, capturing this celestial ballet from a truly unique vantage point. Get ready for a cosmic show. Picture this: astronauts aboard the International Space Station, orbiting high above Earth, witness the breathtaking dance of a total solar eclipse. In a jaw-dropping video, captured by one of the JWST weather satellites, they marvel as the shadow of the moon sweeps across the planet, painting a mesmerizing time-lapse image from the bottom corner, up through North America, and out into space. Now let's flip the script and imagine what this cosmic spectacle would look like from the moon's perspective. While no spacecraft on the lunar surface could snap a pic, NASA's Lunar Reconnaissance Orbiter had a bird's-eye view. Carefully planned and executed, it captured the eclipse shadow in action, a stunning reminder of the interconnected dance between Earth and its celestial companion. But how long does totality last? Buckle up for the cosmic journey. The duration of totality depends on the path of the eclipse shadow as it glides across our planet. From the moment the shadow falls on Earth's surface to its exit, the eclipse paints a breathtaking arc across the sky, captivating all who witness its celestial ballet. Imagine the cosmic ballet as the shadow of a total solar eclipse falls upon our planet, tracing its journey across the vast expanse of Earth. It's not just a matter of minutes, it's a cosmic odyssey that unfolds over hours as the shadow makes its way from one side of the planet to the other. Now, let's switch gears to a question from Sashil Naran about backyard telescopes. The joys of exploring the cosmos from the comfort of your own backyard. But where to start on this cosmic adventure? The world of backyard telescopes is like a rabbit hole of possibilities, offering everything from budget-friendly options to high-end marvels worth a small fortune. For most backyard enthusiasts, a Dobsonian telescope is the way to go. These user-friendly telescopes are perfect for city dwellers, eager to explore the wonders of the night sky. Whether you're yearning to glimpse the rings of Saturn, the moons of Jupiter, or the intricate details of Mars' polar ice caps, a Dobsonian telescope has you covered. And don't forget to grab a solar filter for those daytime observations of our nearest star, the Sun. Picture this: with just a simple Dobsonian telescope, you can unlock the mysteries of the cosmos right from your backyard. These telescopes are like cosmic magic wands, easy to use, yet incredibly powerful. And the best part? You don't need to break the bank to experience the wonders of the universe. For less than $500, you can snag yourself an 8-inch Dobsonian telescope. Now, that might sound like a hefty investment, but trust me, it's worth every penny. With this cosmic marvel, you can gaze at the moons of Saturn, catch a glimpse of Uranus's moons, and marvel at the intricate details of distant galaxies, all from the comfort of your own backyard. And the simplicity of a Dobsonian is truly a stargazer's dream. No complicated setup or technical know-how required, just point your telescope at the sky, peer through the finder scope, and voila! You're treated to a cosmic spectacle like never before. It's the perfect way to impress your friends, invite them over, show them Saturn's rings for the first time, and watch their jaws drop in awe. Now, I know what you're thinking: $500 for a telescope might seem like a hefty price tag. But fear not, my fellow cosmic enthusiasts. If you're a DIY wizard, you can roll up your sleeves and build your own telescope for less than $100. Yep, you heard that right. With a few mirrors, mounts, and a dash of handyman know-how, you can piece together your very own cosmic marvel. So, whether you're splurging on a Dobsonian or getting crafty with a DIY project, the sky's the limit when it comes to exploring the cosmos. But wait, there's more. Once you've got your hands on a telescope, the universe becomes your oyster. Want to capture stunning images of distant nebulae and star clusters? Welcome to the world of astrophotography. A whole new realm of cosmic exploration awaits. First up, we have the budget-friendly option: investing in a tracking mount for your camera. If you're already rocking a digital camera, all you need is a sturdy tripod and one of these nifty tracking mounts, which won't break the bank at just a couple $100s. Simply mount your camera, fire up your DSLR, and let the magic unfold as you capture the beauty of the cosmos with your own lens. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.